Hi guys, welcome to another episode of Design Technology TTB. We are today going to be looking at the OCR NEA A-Level project 2.2, 2.4 and 3.3. This video is going to possibly be a little bit of a long one because of the content that's involved here. I've tried to strip it back, but there's always going to be a bit of stuff where there's going to be me discussing and talking about it. If you need additional detail to this video, then you should be speaking to your teacher. Within this video, we will be looking at essentially the sort of the bulk of your project, and we'll move on eventually to then look at some examples of student work. Because it's such a lengthy video, in the description I'll put some timestamps in to allow you to navigate between 2.2, 2.4 and 3.3. So strand 2.2. It is you doing your design work. You are building models, you should be building a breadth of models, and you should be working your way through to a really solid outcome that is leading to a final design. The progressive nature of it should mean that you're building on previous designs. You should be adding detail, DFMA, and also thinking about how your user, how it will interact with it, how the product will be used, where it will be used, the difficulties in the situations and the variety of situations it will be used in. So an example of this would be, you shouldn't be doing a mobile phone for your major project because it's a really bad major project. But if, for instance, a mobile phone, if you were thinking about the context of its use, you've got everything from how the person actually uses it and interacts with it directly, i.e. their interface. You've then got how it is then protected from knocks and bangs. You've then got potentially how the product is stored, how it's used, where it's used, so it's got to fit in people's pockets or handbags. How do you stop it from getting scratched in those contexts? You've also got then aspects where people will be changing the SIM cards, they'll be plugging it in to recharge it, etc, etc. So a lot of that sort of project would end up being the navigation of the screens, which makes it a bad NEA, so hopefully you're not doing something like that. However, that kind of all those different contexts and all those different environments of use are one then that you need to consider if you're going through this project. The designs should be iterative, so you should be trying different solutions and different approaches to make sure that you're meeting the key requirements that you've identified. Too often what we see here are students who just build standalone models that don't really have any real links to each other. They're purely based around the initial ideas that came at the start of the project. We get sort of 4 or 5 different ideas and they go, oh, there's my final design. That is not iterative. If you don't know what iterative design is, then you have to look that up now. It's the fundamental ethos of the entire qualification, so make sure you're clear what it is. You should be working towards those technical requirements, and those key requirements we've talked about show that you understand what the technical requirements are. So if your product needs to withstand a certain weight, what certain weight is that? How are you making sure it does it? Are you using specific materials? Are you using certain ways of doing it? What are the technical requirements? It being A-level, the more technical requirements and the more detail you go into with that actually then means that you're going into more critical thinking and you're probably going to get a higher grade. You should also be looking at next steps as we work your way through 2.2. Get feedback from people, work out what they want, base your solutions on user needs, and fundamentally get yourself to a stage where you are following a process. So you'll do a design, you'll work out that there may be flaws with it. What you then do is you then say, right, these are the flaws that I need to work on. On the next slide or slides, we can then and should be able to track you navigating your way through and following up and solving those issues. In solving those, new issues might arise, and if they do, you should then be tracking and solving those. In terms of the iterative development, again, Markdown 4 is normal. We're looking for developments are comprehensive. Comprehensive means that we need to see nuts, bolts, details. They should be progressive, i.e. they should build on each other. We should have lots of technical requirements that are coming in, and we can see that you are utilizing them and understanding them and solving and resolving them. And we should also make sure that you are identifying next steps, i.e. you're identifying problems or good points, and then you are then creating action points for yourself and then following them through the development. That all feeds into the chronology, which is another video that you'll be getting from me soon. Make sure that it flows and we can see the process that you worked your way through. If we just quickly flip down to Markband 2, iterative developments are generally progressive. So even to get Markband 2, you have to have some progression in your designs. If you only simply do a few models which are standalone models and do not link and do not iterate, you are not going to get out of Markband 2. Plain and simple. Likely content. It's going to be improvements, and it can go through any methodology you want. So if you want to do it through sketching, you can want to do it through models, sketch models. You could do it through little mini tests. You can have, if you're an engineer, you might have Circuit Wizard, or you might have CAD/CAM. You might have breadboards. You can go about it any way you want. So do the things that work for you. However, remember what I've said in previous videos about getting hung up in terms of the influence of the amount of time you have to put in. And I'm going to show you an example later on where CAD was used significantly throughout the design process, and it actually interferes with the design process and causes the student to get a worse grade because he spent so much time on it. There should be an incremental approach. We should see you being able to, changing little aspects within it and tweaking it and making it better. Something that's really important there, you are evidencing your work to be as clear as possible for the person marking it and also the moderator to understand what's going on. If you've made small little changes, are they obvious? Do we know you've done it? Often I find myself looking at sheets, and particularly when I'm sort of working through with my students, I look at the work and I say, right, what's changed? You're asking me to spot the difference, and the problem is that if that's the case, it's very likely that stuff's going to be missed. So make sure that you evidence what's been changed, and sometimes the smallest of changes are necessary to make your product work. Show us that. It might be that a hole has moved from being 1 mil to 1.2 mil, so a particular part can fit through and into it. If that was a fundamental aspect of the design, we're not going to see that in a photograph very easily, but you should be making sure that it's clear that that's what you've done to resolve a problem. So do that. As you go through, also think about DMFA or DFMA even. Let's get you guys going through and thinking about how this product will be made in real life. If you're not thinking about that, you're not accessing the higher marks. The senior moderator at this stage is really keen on DFMA, and he wants it to be a really strong section. So if that's what he wants, that's what you want to be doing. So you're creating, you're evaluating, you're exploring, you're creating, you're evaluating, you're exploring. It's just rinse, repeat in any order they go through, making sure that you are doing it as you need. So as we've talked about in your investigations and information, if you've got to this stage and there's things you don't know, which is absolutely normal, and that should be the case, you shouldn't have front-loaded tons and tons of research into the beginning. You realize that you don't understand what type of gearing is needed for your solution, or you don't understand what type of capacitor is used in this certain situation, or you don't understand how big someone's arm is. If you haven't gone through those stages and you haven't done that, then as you need it, you do it and evidence it within your slides. That means you need to show the progression you're going through. And something that I will always tell my students is having a sort of set layout of each of your sheets will not work. Make it a bit more fluid, make it so it makes sense, stick in subtitles, stick in aspects that allow us to see what's going on, but don't keep it regimented, because often regimented means you either have boxes which are filled with either rubbish or nothing because you didn't have anything to put in them, or you wanted to show more photographs of a certain product and you can't do it. So don't panic about a slide being a complete unit. Feel free, if you need to, go from one slide onto the next slide and finish halfway down it and then start something new. That's totally normal. As you go through it, let's have consideration of size, cost, materials, manufacturing, etc., etc. Show that you are thinking about these things in your text. You may want a key, and you'll see a key for an example, on the outstanding project that I've done. So if you haven't seen that video, have a look at that. And you'll see that the key follows through and allows the marker, but also the student, to understand what they have done or what they've missed out on certain sheets. Common mistakes. Too few models. It's plain and simple. Students don't engage early enough. They don't spend enough time on this section. They rush it, or they just cut corners and just don't do enough separate models. Remember, if you make a model and it's really good, but it doesn't quite work, you can always adapt to that model, change that model, drill new holes in it, or do other things to it to make it into a second model. That's all part of the process. Importantly, though, you make models quickly, particularly at the start, because you're just trying to get your head around and understand what's going on. You don't want to find out 2/3 down the process that your design is completely flawed because you haven't thought about a key aspect. An example of that, student a few years ago for me was making a chair. It's a really good project, considering how it would fold up and fold down and do all sorts of interesting, exciting things. We got 2/3 of the way through, and I said, I've asked you this before, but do you know how big this chair is and whether it's going to be the right size? And part of its solution was the fact it turned into a bed as well. And we made it full size for the first time, 2/3 of the way through, and she suddenly realised that, yeah, it fitted her fine, but she was quite small. Anyone else did not fit on the bed, and she had to do a total redesign because of that. So if she'd have made a really quick mock-up in the first few days just to understand the overall size, she could have started on that process much, much earlier and made her life a lot easier. You should be looking at communicating all the parts. So as I say to my students, down to the nut, the bolt, the washer, the gear, whatever it is, show us that you understand what's going on. Think about the internal space. Think about what the structure either allows the product to do or limits it because of the design. Is it a viable design? Other common mistakes, too little feedback. So not getting enough feedback. And in both examples I'm going to show you later, both a good one and a bad one, both of them do not have enough examples of feedback throughout it. So bear that in mind. So when you look at it, don't go, oh, well, there's not very much feedback here. That's because they got it wrong. So make sure you get it right. Accessing higher marks. Same as normal, I'm not going to spend a lot of time on this because it repeats a lot of things I've just said, but making sure that you are being critical, making sure that there's clarity of what it is you're doing, that we can see that refinement and that progression. It's fundamental to the whole thing. Throughout this process, you should also be bringing in materials and components. If you look at the mark scheme for 1.5, when we're looking at materials, what happens is that students identify materials at the early stage in their information and inspiration, and then we never see them again. We are looking for you to look at materials. We're looking for you to pick the right ones as we go through. Don't be repetitive. Don't constantly tell me this is aluminium, this is aluminium, this is aluminium. Tell me why something is a certain material. Could there be other options for it? Could there be other solutions? If there aren't, don't keep repeating it because it's pointless, but make sure that you're considering all parts. And because our products are often really, really complicated, if you are going down to the washer, then what you're going to do is you're going to find that there are lots of opportunities, different materials that have to perform different processes, particularly, or different characteristics for them, particularly when they're put into different environments. Into 2.4. What we're looking at here then is the critical thinking for your project. This is basically down to the complexity of what you're doing. So highlight problems. What we're looking for is for you to find problems and resolve them as you go through. It's the ethos of the qualification. Show that you understand what the problems are and that you're dealing with them. Those solutions then should be done in a sensible order. We should be able to track those problems and solutions. If you've got a problem that you've identified that it doesn't do X, we should then see you over the next few slides trying to resolve those issues, and we should be able to track that problem being resolved. So putting in aspects that say my next steps will be blah, I'm going to do X. Here's the resolution of before and after images can be really helpful. And also then the challenge. Quite often students will fall back on the easy route, and what they'll do is they'll do stuff because it's within their skill sets and they go, there you go, done. However, what we want is we want detail, detail, detail. Push yourself. You know, if you've designed something that is someone's going to sit on, how strong does it need to be? Are the materials that you've chosen in the diameters or thicknesses you've chosen suitable for what they're doing? Or have you massively over-engineered it, which means they're really expensive and costly? Is it just an aesthetic choice of why you've done it the way you have? Doing physical tests, doing trials, showing that you're planning on using the right equipment and the right components is absolutely fundamental. So you'll see some examples later on where a student is looking at the spring calculations for a sprung mechanism he's doing. And also, again, DFMA, looking at this design for manufacture and assembly. How are you meeting those requirements? Within critical thinking, we are looking at Markdown 4, so systematic and effective responses to all identified problems. So you should be identifying the problems. Some students then look at this and think, well, if I don't identify problems, then that's no issue. However, you need to be identifying problems. It's what this is about. If you're not identifying problems, if you don't have an approach that is clear, if you aren't resolving and responding to those issues, whether it's coming from feedback, whether it's coming from tests, whether it's coming from user trials, whatever you're doing, if you're not responding to that, you're looking at mark band 2 probably, or maybe even less when we look at superficial being the bottom and then some effective responses. You're also looking for innovation. Now, what that is it's not you coming up with really crazy creative designs. What it is coming at this problem from an interesting standpoint and doing things that aren't necessarily the safe, easy option. Play with the options, try different things, even if you think it might be a little bit out there and it's not necessarily going to work, but it might offer, there's got to be a valid reason for doing it, but it might offer some interesting way of approaching it or might offer some unusual solutions, then go for it. Don't get hung up on the innovation though in the mark scheme. It's not something that is really, really impactful on how you go. So focus on the systematic approaches, and what you'll probably find is that as long as you're doing enough different bits of modeling, that you'll be able to access the innovation because you'll trial enough different options. On that note, critical thinking is tied very closely to 2.2 and the number of models you've made. If you haven't made enough models in 2.2, you're not going to get a good mark in 2.4 either, because you can't have systematic and effective responses to all identified problems if those problems, there's only a few of those problems. There needs to be a good amount of problems and robustly challenging each of those. Providing you do that, you're accessing the higher marks. So make sure you get started early and move on quickly. Likely content here is you recording the problems and showing what you're doing. As I said already, planning your next steps, making sure that's clear. Because you're doing this in real time, audio, video. Videos are great for this sort of thing because what you're doing is you can explain what's happening, what the problems are with a model, show it articulating and moving and saying this doesn't do this hole doesn't match up with this piece, this doesn't fit this component can't fit here. It's really quick, it's really succinct, it's obvious what's happening, and it allows both you, the marker, and also the moderator to understand how you've gone about it. On that note, the moderator will not click into every single video, so you want to signpost what's going on in your videos. I've probably mentioned this before and I'll probably mention it again. In your videos, what you want to do, have your video, they should be about credit card size on your page, and then underneath them are, you want to bullet point the key points that you have mentioned in the video. That allows then the moderator to understand what's going on very quickly. They will look at some of your videos to understand the style of delivery and the content that's within them to get an understanding of how critical you're being within the videos. However, you want to make sure that they know that all the videos that are there have a certain content, and also you want to guide them through it because they won't click on everyone. So telling the story as you go with subtitles and also bullet points of both positive or negative information is really useful. You should never find yourself doing a silent video. Always talk over it because there's always marks involved in doing that. And then, as I said, innovative methods and ideas of ways that you can meet the user needs. Common mistakes, low-level simplistic modeling. So it never gets to be anything that's more high-end. That limits your critical thinking marks because you're not pushing the higher levels and the higher difficulty. You should also be making sure that you don't just rely on the fact that critical thinking is inherently part of the process. Yes, if you're looking at designing a gearing mechanism and you're working your way through a series of stages and you're looking at the gears, yeah, there is inherently critical thinking within that because you're working through the process. Good. However, record it. Quite often students miss out really key links or key moments within the design process because there's no evidence of them, no photographs, and they just can jump from one to another. It's clear that something's happened in the middle there, but without that being evidenced, it makes it very difficult for the marker and also the moderator to award you marks. Show us the steps and stages, even if it's a really clunky, rubbish looking model. There's a quick photograph that was the missing link in the process. That's spot on. Accessing the higher marks, so real-time recording, an approach which is systematic and picks up on all those different issues that you're doing, strong evidence that you're working through an iterative process and meeting those key requirements. Challenging is fundamental, so make sure it's challenging as you go through. It should be challenging you. Try new things, see what happens. Don't do the safe stuff. Okay, strand 3.3. Here what we're looking at is then the different ways you're doing this. Unfortunately, I've got a box in the wrong place. So we're looking at clarity of designs and how you're actually putting over the information, the layout of the work, how you are using annotations in the right way. We've then got a range of different techniques. Are you trialing stuff? Are you making it to high quality? On that note, don't waste your time, mentioned it before, and then showcase some of your skills to make sure that they are excellent, but not all the time. If we look at our design developments, Mark Band 4. The range of communication techniques, you'll notice there's an asterisk here. That is because digital design and manufacture is not included in 3.3, it's marked in strand 4. So bear that in mind. So it doesn't matter how nice your CAD is here, it's marked somewhere else. That said, one of the things that is a very human response is when you see work, if it looks awesome, you're inclined to give them higher marks. If you drop bits of CAD within your design work, which is obviously marked elsewhere within the design developments, it's going to be very difficult for the moderator and marker both to look at it and not take it into account in some aspects. So I would still push, say, do really high-end CAD as you work through, show how good you are. It's an ideal opportunity to do it. And of course, it will be marked elsewhere, but you might also accidentally pick up marks in design development too. So we're looking at a range of excellent approaches, making sure that you're developing and communicating your design skills. So it's the quality of the models mixed with then how appropriate they are for the level and the depth of communication you're putting across. Likely content, so a range of different models. You might have cutaway views, you might have sketching that shows us what's going on, we might be experimenting, we might be communicating, developing designs as you go through, make lots of models, etc., etc. And as I've already said, use of full-scale models to communicate ergonomics can be really, really useful. What we want also within this is then dimensional and functional suitability popping up. That obviously is difficult with architecture. So with architecture, you might make a model that allows you to walk through it. You might do other aspects. With architecture, and I'll probably do a separate video on this, a very short one, be careful about how you're approaching architectural models. The architectural model has to be a product which has a system within it. It can't just be pretty buildings. So prefabricated buildings, those sort of things, flood defences are regular projects from my students because they open up those marks. With architecture, then you can make models that are scale and show how they fit, the products fit together. You're not expected to do anything that's full scale because that would be ridiculous. Common mistakes. Too few iterations, just not trying enough different aspects. Make lots of models, plain and simple. If there aren't lots of models, then you're not going to get high marks for the quality of the models because there weren't enough of them to show a breadth of evidence, and it's all about that breadth of evidence. Complexity. Doing really simple models at times is totally appropriate. However, there has to be bits where you show off a bit, show the complexity, show the quality of what you're doing. And then rigor and challenge again. Simplistic models are just easy to do, so you can't show high quality modeling skills in a really simple model, or you're going to struggle with it anyway. So look at the marks. Show that you are present your work with clarity, do it professionally, make it look really high level at times, but particularly make sure that you pick the right quality for the right moment. Okay, we're going to look at some work now. It's out of context, although I have tried to do it in the order it was submitted. Both examples have limited feedback. It was an error for both students. They didn't do what they should have done at the time in terms of putting in the levels of detailed feedback. So bear that in mind. These are not good examples of feedback. Not all the sheets are shown. So look at the mark breakdown that's been on previous sheets to understand where we're going with this and why I'm saying the things I am. This is a leg brace project, a really nice project with lots of component parts. This is coming out of the initial ideas. This is like the end phase of his initial ideas. As you can see, there's some clarity of sketching. He's trialing some bits. He's also popping in some information based around possible units. So he's got Herf gear that's popped up here, and he's got some sprung units, etc., etc. And his first step then is to make something. So you can see he's saying next steps even here. He's showing that he's guiding his way through. This is his first model, so this was actually initial ideas. You might have seen it in the previous video if I included it, I'm not sure. There's been a bit of a space in time between now and then, but it's a nicely made model. It's got a couple of springs in it to allow it to function and work, and we can see how in principle it would work. You You can see that the springs are actually sketched in the bottom view, and then the final one actually has the springs. The video shows it working. We then have iteration of it. So this is the next step, and you can see there's the model changes slightly, and then he also does one in clear where he's playing with it so you can see the internal components. Again, he's highlighting problems, what the important aspects of it are, and then what next steps he's going to do to try and resolve those issues. What he's doing. We then have a third one, so he's playing with it even further, he's triangling new things, he's showing his understanding of the amount of motion that's needed to work for his product. He's then going back and he's thinking about the motion that someone needs as they're walking upstairs. The product is then being played with further, and he's manipulating and changing it to make sure it is fit for function. You'll notice that the next steps continue. Some of them are quite simple. Make a model for the healthcare designed to test feasibility. Fine. But what they're doing, they're based around the stuff that he's already identified here. You may be better off making sure that you actually show more thinking in terms of critical thinking about why you're doing the things you are. So this is his first HERF coupling. Didn't spend a lot of time trying to make a really high quality model. He bashed it out with some foam. It's quite rough and ready. However, in the video you'd have seen that he actually, even though it was really rough and ready, it was actually quite a strong gearing, and it even in foam worked really well. So he then decided that he'd CNC a version of it, and here he then makes it. So he's made it in CAD, and he works his way through showing that, and he's linking it to some of his design work and also through to the research that he's been doing. That then builds again. So now it's more complex, there's more component parts. He's showing it with the attachments that are going to fit. He's also thinking about a switch mechanism that's going to attach to this and allow it to function. So there's, as you can see, there's two different aspects that are starting to amalgamate here. Into the switching. So we've got model 1, which is based on his original sketch, and he's thinking about how that might work. He then tests it to see what happens, but there are problems with it and it doesn't function properly. He then makes model 2, he then makes model 3. What he's doing is he's highlighting how the things work. Not always is it totally obvious what the differences are between the different aspects. That would have been useful, and if you read the text more carefully you can spot that, but it could have been have more clarity in terms of what's going on there. At this point he then moves into some investigation of electronics to do it, so a bit more research. So you're seeing the chronology throughout the project here. He then goes back to sketching because it's an appropriate way of understanding what the whole product is going to look like in its entirety. Gets a bit of user feedback. As I've said already, that comes in too rarely. Then he starts modeling. So he goes back to cardboard. He's not doing something that's really complicated and really heavy going. He's gone back to the simple things, the quick things, to allow him to work his way through. He does then more of those because they're successful, and he starts testing the frame, getting other people to trial it. Now, in the video, the guy talks about it. It would have been much better if the feedback was more explicit and we actually got more information about what these two guys thought at this stage. That didn't happen. However, it moves on, and then he looks into then adding a torsion spring to give it more strength. He's referring back to his original product, so you can see how it's building on itself. And then into our spring measurements on the right-hand side. He's showing that he understands how strong the spring needs to be, and all he's done is use an online calculator. However, that is critical thinking. In its inset, you can see how it's working and how it's building into the project. Now we're going to look at something else. So this is one that's built on from the initial ideas. If you've seen the initial ideas, you've already seen this project before. It's a very simplistic change from what was an initial idea to apparently now being evaluation of development. I can't and don't see any real development here. Something that's really important is as you do development, make sure that you're making meaningful changes. Unless a little tiny change makes a big impact, there's really not a lot of point in talking about it in much detail. So the student has gone from having a CAD model of the outside, and then suddenly we've got this pulley mechanism made in CAD. If you look at the right hand side on the top right corner, it says where it would be welded. Look at the detail of the model. Why is it this detailed at this stage when it's the first model he's made? So what he did is he spent absolutely ages making CAD models, and it actually impacted on his final grade because he didn't make enough models. I have no idea why he did this. I told him not to. Seemed quite keen to do it anyway. So we've got some details here. He's not learning a great deal from it because he can only see it virtually. It would be much better if it was a physical thing in real life, although he has some peer review, allegedly. He then changes it. Um, do we really understand fully what he's changed from one section to another? Possibly if we read through some of the text, but those changes are fairly minimal. We're not entirely sure why he's made those changes. A little bit of evaluation, again, comes from him, not the user or someone else talking about it. We then get into here. So this CAD is now even more complicated. We've got some really high quality CAD. There's no doubt about that. Bear in mind it's not marked in 3.3. However, the CAD's lovely, but we don't know why he's doing it. And there aren't any trial models because he can't trial it because it's all virtual. Then we get housing version 1, but there was no picture of it. Then we get version 2, again, straight back into the CAD. So he's just modeling using CAD. There aren't any real changes here. What there are additions. So what he's doing is adding to the model, not changing them as we saw in the previous project. Then we get another version. What this is based on, why it's changed shape, you can find out in the text, but it's really not very clear. The lighting of the CAD is really bad as well, but the details are great. I mean, if you look at the component parts, yeah, fabulous. I mean, it's a really nice bit of CAD. It just really wasn't the way to do this. If this had been done at this quality alongside a whole load of models that explained how this gearing mechanism was going to fit on a push bike, where it would fit, why it was the way it was, etc., etc., this would be worth a lot more marks. Unfortunately, because it's done in CAD alone, doesn't pick up those marks because there aren't the range of iterations, there aren't the obvious changes as to why he's changed things, and it doesn't make sense as to why he's gone down the routes he has. Into the final design, lots of component parts here. We can see the O-rings, he's thought about washers, he's thought about all sorts of stuff. As we said, nice bit of CAD, but does it meet the iteration of a design project? The answer to that is no. What we get is we get a series of standalone component parts with some similarities, some aspects, but in terms of meeting the core requirements that are in the mark scheme, it doesn't do that. Okay, so next up is going to be 3.1. It'll be chronology. I've managed to get this completely wrong. Will be 3.1. Most of you won't have stayed to this point anyway, so it doesn't really matter. We'll be looking at chronology, and we'll be talking about that. If you've managed to get through this garbled mess. Hopefully, UDTV has been useful to you. Like and subscribe has been useful. Thanks very much for watching.